Hey guys, I'm Pamela.
I'm Sophia.
And I'm Kayla.
And today we're going to be teaching you how to find the vertex of a parabola using factoring and symmetry.
Factoring is a way of using factors of a number that when multiplied create a trinomial and quadratic expression.
A parabola is a set of all points on a plane that are equidistant from a fixed point on the plane and from a fixed line on the same plane that does not contain an A-formation fixed point.
As said above, this method utilizes symmetry, which in this case is the exact line of the division of the parabola.
You can only use this method if the parabola crosses on the x-axis of the graph.
There are many ways to find the vertex of a parabola, but this way we can know if the parabola has a line of symmetry.
This will make us get to the solution much faster than by completing the square.
For example, we can use y equals negative x squared minus 6x minus 8. You would then factor out the negative 1 from the negative x squared, which would get you y equals negative 1 x squared plus 6x plus 8. Then we get the factor form of x squared plus 6x plus 8, which will give us y equals negative 1 parentheses x plus 4 parentheses x plus 2 parentheses.
This factored form tells us that the equation has a value of 0 when x plus 4 equals 0, when x equals negative 4, and when x plus 2 equals 0, when x equals negative 2.
So, the parabola crosses the x-axis at negative 4 and negative 2. But, since the parabola is symmetric, the line of symmetry must be halfway between these 2 points at x equals negative 3.
This tells us that the x-coordinate of the vertex is negative 3.
To find the y value of the vertex, we simply substitute x equals negative 3 in the equation. It's probably easiest to do this in the final factored form shown above, which is y equals negative 1 parentheses negative 3 plus 4 parentheses negative 3 plus 2 parentheses equals negative 1 parentheses 1 parentheses negative 1 parentheses equals 1.
So, again, the coordinates of the vertex are x, y, negative 3, 1.
There are many places that parabolas are hidden.
For example, the lenses of eyeglasses are parabolic surfaces that collect light and focus it.
Your eye lens acts as a parabola. The retina lays at the back of the eye.
If it is functioning properly, images can be focused on the retina.
If the shape of the lens is not formed correctly, images cannot focus.
If the focal point is either in front of or behind the retina, the image will be blurry.